Now, of course, we'd like to get proceeded to the next part of today's agenda. At this point, we'd like to give our thanks to our sponsors for today, BMI, for sponsoring today's seminar. Let's have a round of applause for BMI. And now I would like to invite our sponsor, Miss Angeline Goh, the Specification Manager, onto the stage to present the product talk. Let's give her a round of applause. Thank you very much.
Hi, good morning, everyone. I'm Angeline. So I will take about 50 minutes to go through my company profile and the product TPO with the trade names as BMI Everguard TPO. In my presentations, I will divide it into 4 parts. First, about the BMI. Second, what is TPO membrane? The third one, our BMI Everguard TPO system. And then lastly, I will cover the projects in Malaysia and as well as in overseas. So BMI stands for Blast Monia Icopal. So most of you are familiar with Monia. And then we have a new name, the new company name called BMI. So today, we are talking more about the flat roof and waterproofing. So this product will be more likely fall under Icopal. We are BMI. Our parent company is Standard Industry. So under this umbrella, we have a BMI, GIF, and as well as other waterproofing company like Grace, as most of you may have heard before. So for BMI, we are established since 1852. We have close to 9,000 employees over the world. We have 128 manufacturing plants, and our HQ is in UK, London. So for all the product brands, we have pitch roof and flat roof and waterproofing. So for today, we will more focus on Everguard TPO. So back to Malaysia, we have 9 manufacturing plants and 9 delivery service center, as well as 8 sales office. And we have 2 BMI academics. One is in Rawang, another one is Bukit Kemuning. So this academic is actually for us to train our applicator, and also if let's say our consultant or architects were interested to know how to make the installations, you can always come to us, and then we can allocate a training section. So the second part, what is TPO membrane? So this is a piece of TPO membrane. So later after this seminar, if you have some time, you actually can go back to our booth outside. We have a few sample to giving out. And then for those who come late, you can actually like our social place like Instagram, and then you can redeem a free gift. If after today's you feel that you want to refresh our build-up sample, you always can come back to PAM Center, our gallery. We have a booth over here, and then our sample of the system is always displayed in our gallery booth. Yeah. So for TPO membrane, it stands for Thermoplastic olefin. Yeah, this is a chemical name. So for the layman like us or contractor, we always say TPO membrane. So this is the most popular choice for the commercial flat roof. So we are using this membrane to prevent the water leakage enter the building on the metal structure roof, and also it can be used on the RC flat roof. So this is a data show from the US commercial roofing market. It shows that 4 different types of membrane like EPDM, TPO, PVC, and plastic, we call it like bituminous membrane. It's only that TPO show that's the increased usage over the almost 20 years. Yeah. So this is the reason why is choosing TPO. First of all, It has an excellent performance because it also provide a great value. In terms of that, it's meaning that cost effective. And then it give you the seam, which is a hot welder seam strength is excellent compared to others membrane material. It give you a long-term weathering, as well as because it's a white color membrane, it give you more energy saving. And then as well as there is some others like natural fungal resistant. So for BMI Aerogard TPO system, this is just now the commercial video you are already very familiar. It's a whole piece of membrane. And then the systems is included. We starting from the bottom. We have the vapor barrier. And then second, we have the insulation layer. We call it PIR. And then the finishing will be our TPO membrane. So the whole system that we provided is included the patented fastener and plate, as well as some accessory. Yeah, we are not selling only piece of membrane, but we are providing you the whole system for the roofing. So the system can be installed on top the concrete as well as the metal deck. So generally we are giving you this art or a state of art in the market, and it give you the highest durability, as well as we can calculate the higher wind uplift value, which is all the system is FM approved. Yeah, if some architects or consultants are involved on this commercial roofing for the investment company like electronics or pharmaceutical or logistic, they may concerns on the FM global. So our system is already registered, and GIS is both sister company. We are sharing the same technology and patents papers. So for this attachment, we are going to show only one system. We call it Rhino Bond. So for this quick video, I will show you this how is the mechanic assembly by the amination. Yeah, can you help me to play it? Thanks. Yeah, this is one of the attachment system that we are going to present by our technical manager, Mr. Lim, later on. And beside this TPO membrane as a finishing, you always can do some solar panel. We have some accessory like anchor to install on that. Beside solar panel, if let's say you want to inverted the roof becomes a garden roof, this membrane it will also proven as an anti-root. It can reduce for the landscape. So for BMI, we are flexible. We can undertake a project supply and install, and then we do provide the shop drawing design. If let's say the contractors are going to use the BMI system, we are provided a 20 years system guarantee. So the whole set of system is already in supplies for the whole world is more than 320 million meters square. So our TPO membranes is best performing in the market, you can search, which is the website tporesult.com, to have a review. So we only giving provide the complete roofing solutions. We also will provide the qualities, we say, approved roofer for our clients, and also to secure the projects, so that the whole system is actually include, beside the specification, design, workmanship, we also give you a comprehensive maintenance program. So imagine the roof that can last for 20 years. It must be some regular maintenance that annually they had to go through. So no worry, BMI do have this program as well. So lastly, not taking so much of your time, I will just go through some of our iconic projects in Malaysia and overseas. So we have a lot of projects focused in Penang, Batu Kawan. As you know, that is a booming area now. So we have Micron. We have already currently ongoing. This is the phase 1. We are ongoing for the phase 2 as the same size. We have completed the lump research. Yeah, so the white color roof is actually a membrane roof. A small scale refurnished projects for the RC roof in the resort. Luminous plant to Penang. Pangkal Laut, we have a video just now. IKEA in India, Kia Motor, and Olympics in China, and then another Hyundai Motor in Indonesia. Yeah, so I have completed my presentation. Now I'm going to pass our stage to the speaker. Thank you.
Thank you, Ms. Angeline Goh. 320 million square meters. Oh, that's a lot. That's really a lot. Okay. Thank you very much again for that presentation. Yeah. And now, without further ado, I'd like to call upon our first speaker for today, Mr. Lim Yong Siang. But before I formally invite him on stage, I'd like to give you a little bit of bio as to who the gentleman is who'll be presenting shortly. Mr. Lim Yong Siang is graduated with a bachelor's degree in engineering, mechanical, from the University of Science Malaysia in 2004. He has a total of over 18 years of working experience in a research and development environment, and he started out as a research and development engineer for Shimano Components, M. Sendiam Berhad, just after graduating from the University of Science Malaysia in developing various bicycle components. And he's responsible for designing bicycle hub and wheel for various product segments from low to high end to mid end. And of course, his major expertise is in mechanical design. I think most of us might have owned the Shimano bike when we were growing up, and I definitely enjoyed mine. So I'll be looking forward to your presentation as well. So now I'd like to take upon this opportunity to call upon Mr. Lim Yong Siang to come on to the stage to present his product for today, Thermoplastic Single-ply Waterproofing Roof System. Thank you so much. Can you please come onto the stage?
Hello. Good morning, everyone. My name is Mr. Lim. You can call me Lim. And before we start the presentation today, just want to make a quick survey. How many of you is doing a project using a TPO membrane before? Can you raise up your hand? And how many of you is doing project using a bituminous system? Okay. So this is a good sign because Angeline have a very market to offer. And okay. Single-ply membrane roofing is we call it as Actually, TPO membrane, PVC or EPDM, we call it as a single-ply membrane roofing. And for bituminous system, we call it as a multiply membrane roofing. The reason we call it as a multiply for bituminous because for bituminous system, we need to have 2 layers. And compared to single-ply membrane roofing, we only need one layer of membranes. So that is make it much more efficient to lay on top of the roof, and on the same time, it's cheaper. Okay, so this is the current roof, which is previously for the roof is conventionally is used to protect the occupants from rain and sun. But at this modern era, the roof is used for more function, like example, to generate electricity or as a recreation area. That's just an example as a green roof. So what is the function of green roof? As you know, for Singapore HDB, currently all their HDB is already covered with a green roof for the new project. So the reason they want a green roof for their HDB is to reduce the heat island effect and also to reduce the issue of stormwater runoff during the raining season. So this is the function of green roof. And for Malaysia, we can do so also using TPO membranes from our company. And in other foreign projects, such as in France, they can create a football field over a car park. Okay, they also can do a running track over a student accommodation. So there's a lot of possibility. You can use the roof. So we go to the Tpo Waterproofing Solutions. So this is the common cause of leak on a metal roof due to the open seams and due to the fastener backing out. And also opening in penetration flashing. All these defect on the metal roof is due to the shrinkage and expansion and contraction during the expose of the roof on during the sun, under the suns. So this caused the metal roof to be leaked over the time of servicing. And also the metal roof is also subject to oxidation due to the quality of material you use, and also due to the fastener. Example, let's say you are using a stainless steel fastener onto a metal roof, then it will corrode easily because of a dissimilar material in between the metal roof and the fastener. So this is all is the cause of leakage onto a metal roof. So that's the reason we are introducing a TPO membrane roof. Firstly, it's very cost effective. And for the costing wise, you may check with Ms. Angelique. Secondly, it's fast and easy to install. You can cover 300 meters square in a day. And excellent durability and longevity. The warranty starts from 10 years onward up to 25 years. Superior leak resistant due to hot air welding seam. All the welding seam will be checked 100% during the installation time. Lightweight waterproofing membranes and reduce the impact on structure. System weight with a U value of 0.4 is around 12 kilograms per meter square, which is a very lightweight compared to other type of metal roof system. This is due to the insulation itself is very lightweight compared to the mineral insulation. Complex geometry is able to be achieved. So this is some of the, in terms of aesthetic wise, you can use different type of color of membranes. And it can be used on the vertical as well as a horizontal solution to the cladding system. Some people may prefer to use, sorry, the wording is run off already. Some people may prefer to have a metal roof looks, but you want to have water tightness of TPO, you can do so using our thin profile. So you can see all this project is using a TPO membranes, but we welded with the same profile. So you have a metal deck look. And the TPO membrane is also can be used for a green roof. Okay, for this example, all the membrane need to be approved under FLL and EN 13948. Okay, not all the membrane is suitable. We will recommend that type of membrane which is suitable for green roof because of the root penetration issue. So key benefit of TPO membrane roof is mechanical and thermal performance. So later I will show the graph, what is the thermal performance and mechanical performance. Environment perception as a green product, we have a very high SRI value. So you will reflect all the radiation from the sun. And typically for a TPO roof, it will be easily 10 degrees Celsius cooler compared to the metal roof. And high stability and no plasticizer. So plasticizer is normally used to soften the material, especially in the PVC. So let's say you're using a PVC membrane compared to TPO membranes. Then there's a risk of plasticizer migration in the PVC membranes. Okay, when the plasticizer migrate out, the membrane will become hardened and will become leaks. So for TPO membrane, we don't have this issue. High durability, as I just now mentioned, we can give a warranty 10 years onwards. Chemical resistant and a superior wind uplift value. So this is the reinforcement inside our TPO membranes. You can see the TPO membranes. Let's say you have a TPO membranes on your hands. So this is a TPO membranes. In between the gray color and the dark color at the back, we have a sandwich with a reinforcement screen. So this reinforcement screen will give a higher wind uplift for our product. So we compare with other competitors. Okay, so the brand B is this brand. The brand B is this brand, give a superior in terms of wind uplift compared to the brand S. So you think the brand S is which one? They are very famous in Malaysia. Okay, this is a TPO properties. We compare in between the standard. The standard is we are referring to the Astm standard for TPO membranes. So for our product, the thinnest one is a 45 mil. So 45 mil is a 1.1 mm. And 50 mil, which is 1.27 mm. Extreme, which is this is suitable for the green roof. And you can see our seam strength. Seam strength is a welding strength. Welding strength between the TPO membranes is easily double from the standards. And for the extreme version, it will be easily 2 times plus compared to the standard requirements. And for weather resistant, I don't spell out everything. It's very high compared to the standard. So we go through to the installation. Okay, so we have a different type of installation method on different type of substrate. So we have 2 types of substrate, which is commonly used in Malaysia, concrete, and also a metal deck. So now, before I go further, so I want to highlight that for the concrete, we recommended to use a C20 grade and above. And for the concrete, you need to age 28 days before we start to installation. And for the concrete, the best is 1.2 degree and above to avoid any water ponding issue. Because normally architects have a concern of water ponding, and it causes the roof to be very aesthetic-wise, it's not clean. And let's say you want to have a positive drainage, you need to have a 1.2 degree fall. Can I remove my mask or not? Okay, so for metal deck, it's the same. We have some requirements. 1.2 degree or fall, avoid any ponding issue. For metal deck, it's the same also. And thickness is we recommended 0.6 mm basic metal thickness because of the fastener. We don't want the fastener to be easily pulled off from the roof. So the minimum is 0.6 mm onwards. So the application method, we have a mechanical fix. We have fully adhere. So mechanical fix here is referring to the membrane is a mechanical fix onto the deck. And fully adheres means that the membrane is fully adhered using adhesive instead of mechanical fixing. And we have a ballast also. So ballast means that we loosely laid the membranes. After that, we will put ballast on top of it. So our ballast, we need to calculate. Let's say for this certain area, we have a very high wind uplift. So we need to have, let's say, 40 kilogram of ballast per meter square. So that will be given by our site also. And for green roof, it's also possible. And today we will highlight more on the induction welding because this system gives us more warranty, additional 5 years for the same thickness of a membrane. For example, a 45 mil of membrane will give 10 years minimum for mechanical fixing. But once you choose the Reiner bond, we give it 15 years. So before that, I will go through how to install a mechanical fixing. Firstly, we need to fix the insulation to the deck. So let's say you are using RC, it's the same. It's only the difference of fastener we will be using. Then after that, we will fasten the TPO membrane at the edge of the membranes. So once you fasten at the edge of the membrane is already penetrated. So you will ask me, there's a water leakage issue? Because the membrane itself is already penetrated. Okay? Yes, there's a risk. So that's the reason we have overlap with another layer of TPO membranes. Overlap with another layer of TPO membranes. Then we welded it. And this welding area will be checked by the installer 100%. And normally we will ask the people who do the welding, cannot check the welding quality. It must be done by another person. Okay, because we want the thing to be correctly judged. Okay, they say it's done by the people who do the welding, so they will just say that, oh, it's okay lah, no problem lah. So the best is find his enemy at the site and they check it correctly. And also we can do is AC fixing. So similar, firstly, we want to secure the insulation first, then we apply the adhesive on both surface, the insulation and also the TPO membranes. After that, we will flatten the TPO membrane on top of the adhesive. So we go to the induction welding installation, which is just now, Angeline already reviewed a bit. So this is where we install the vapor barrier. Then followed by we install the insulation. Then we fix the Reiner bond plate on top of the insulation. Then we lay the TPO membranes. Then we do the welding to join two different rows of materials. Okay. At this stage, we consider the roof is already dry because there's no exposed area which is subject to the weather. Then we do the induction welding process to fix the membranes. So this is a process which just now Angeline shared. Firstly, we heat up the plate, the TPO membrane plate. So the yellow color is the adhesive. So once this yellow color is heat up using the induction welder, then we will use a magnetic pull to compress the TPO membranes with this plate and cool it down. So I believe you all have an induction cooker or heard before induction cooker. So this is a similar concept where they use a magnetic to heat up a metal. And this concept is used in the roofing industry. And for the gold color is used for TPO, and the black color here shown is used for PVC membranes. So why we are using an induction welding system? Firstly, this is quick and easy to install. The reason I say it's quick because we only need to drill one layer of fastener compared to mechanical fixing where we need to drill 2 times. First time is to install the insulation. Second time is to drill onto TPO membranes at the edge side. So for Reiner bond, it's not required. We only need 1 time of drilling process. Dual plates and a fastener, of course, we only need 1 layer of a fastener, then it's a dual plate compared to the mechanical fixing. No membrane penetration, and that's the reason we give a longer warranty for this random induction welding system. And even wind load distribution. I will show the next slide what it means by even wind load distribution. So this is the even wind load distribution. You can see for mechanical fixing, all the load is concentrated on the edge, but for the induction welding, it's separate evenly throughout the whole area. So that's the reason it gives better in terms of wind uplift and distribution of loads. And one thing is very important, always a project, they require the roof to be dry faster so that all the installation, mechanical installation or any furniture installation under the roof can be done as soon as possible. So that's the benefit of a random bond system. It dries faster compared to others, the two method, which is a mechanical fixing and a fully adhered system. The reason is you can see we only need to attach the insulation. Then after that, we position the membranes. Then we do the seam welding. So at that stage, it's considered the roof is dry already. So for mechanical fixing, we have another layer of fastening need to be done. Then after that, we need to do the seam welding. At that stage, after the seam welding completed, the roof is only considered as dry because we have a penetration onto the Tpo membranes for mechanical fixing. And for fully adhered system, of course, you apply the glue, it takes more time compared to the drilling process. So that's the reason it takes longer time. So we already cover how to fix the membrane. It can be a mechanical fixing, it can be a fully adhered system, it can be a ballast system, which we are not covering today. But once done, all these three types of choice of fixing, even ballast system, we still need to have an angle fixation. So angle fixation means that at the perimeter of the roof, let's say you use a ballast, so at the perimeter of the roof, you still need to fix using a mechanical fixing. So that's the reason we call it as an angle fixation. And let's say you don't do that, your roof will be shrink and move horizontally. Okay, this is something that we don't want to see on top of the roof. So this is a very fundamental design for a Tpo membrane roof. So this is already mentioned. Mechanical fastening of the field membrane is always required at the roof perimeter. Angle change above 3 degrees and any details. So let's say we have a skylight, we have a parapet wall, we have a step, gutter. All this is required to have a mechanical fixing. So this is a type of fixing option we have. We can use a fixing bar. So the fixing bar is normally for quality product. Normally we will use aluminum extrusion, aluminum bar. For some others competitor, they will use a galvanized bar. So that is not so preferred because it will corrode over the times. And we also can use a screw and plates. It depends on the requirements. And normally we will fix onto a better structure, a stronger structure. So for penetration, any penetration on top of the roof, it depends on the size of the penetration. You need to decide 3 fastener or use 4 fastener. It depends on the penetration sizings. Okay, so that is the fundamental of the Tpo membrane design. So we need to consider type of installation method you prefer. So here we are promoting a induction welding system because we give a longer warranty, even wind distributions, and it dries faster, so the project can proceed faster. Okay, so now I will go to another topic, which is retrofit. So means that the retrofit here means that let's say you have a metal roof. In Malaysia, I think over 90% of the roof is a metal roof for commercial. And normally the roof itself will have a lifetime of 20 years or 15 years, it depends. But once the roof is facing issue, leakage issue, and there's operation under the roof, then you can't tear off the roof and redo. So that's retrofit roofing come in. So this is a typical metal roof which is facing leakage. And this project is located in Penang. They are the chip maker. Okay, you have inside your laptop the chip. So firstly, I go through what is the benefit of retrofit roofing. It's quick and to install, can be installed directly over existing metal roof. We don't need to tear the roof. Membrane is lightweight and does not require additional roof truss. No building disruption. Operation can be continued. And no odor issue or no fire hazard issue. We are not using a touch-on membranes. Save money, high SRI value, and high energy efficiency because we added extra insulation during the process. And for high SRI, it's actually beneficial for a PV system. Let's say you are using a PV system you are installing a PV system on an old roof. Some irresponsible installers say that you can really install on your existing roof. But bear in mind that the PV system can last for 25 years or 20 years, but your roof is already an old roof. Okay, let's say you install onto the old roof, then you are facing some leakage issue. You need to remove the PV. So that is an additional cost for you and it's very troublesome. So the best is to retrofit the roof first by installing a high SRI value surface, which is the TPO, and it can give you better in terms of efficiency for the PV because of the low temperature of the surrounding. So once you have a low temperature of the surrounding, the PV system will be more efficient compared to hot environments. Okay? So you can check this information in the Google, and it will show you that low temperature environment PV will work better. Okay. So this is a typical cross section of TPO metal retrofits. We are using induction hot air welding, and we secure the fastener onto the purlins because we don't know the existing roof. Just like I mentioned before, our metal roof must have some requirement, which is 0.6 and basic metal thickness. So let's say the existing roof is only 0.45 or 0.5. So it means that the fastener cannot secure onto the roof because the wind uplift will be facing issue. So that's the reason we always secure to the purlins. And for the metal deck, let's say the opening of the metal deck is very wide and it's not suitable for us to put the insulation. The insulation will break apart. So that's the reason we have a filler. We call it as a filler to fill out the gap. So once we fill out the gap, then only we lay the TPO membrane on top of it. So this is the structure you can see on the slide. So this is the actual site condition. We have a TPO membranes on top and a PL insulation and come with a PL foot filler. This is a condition after we done the retrofit, before and after. So this is a very high potential project. You can approach your clients and to convert their existing roof to a TPO roof and solve their leakage issue. Okay. So we move on to the wind uplift. So wind uplift is very important topics which is we need to consider during the design stage. It means that we need to calculate what is the wind uplift for that particular project. The wind uplift is very depend on this is a condition. Let's say you never do the calculation properly for the wind uplift. So the brown color is all the insulation. It's already tear apart and you lost millions of dollars because of the mistake in the design stage. Okay. So typically we have a negative pressure and a positive pressure in the roof, on the roof. And wind uplift is very depend on the geographic location of your roof. Let's say in Malaysia, we will put 85 miles per hour in terms of geographic location. And building geometry, of course, the highest the building, the wind uplift is highest, and also the width and length, terrain surface roughness, where is the location of your building. If your location of the building located near to the sea, of course, the wind uplift will be higher, requirement will be higher. Let's say it's located at the center of a KL, the requirement is not so high because the obstacle from the nearby buildings. And enclosed classification is either open, enclosed, also partially enclosed, and parapet is also very important. Let's say you have a continuous parapet around the roof with a 1 meter height, then the wind uplift requirement will be lower. Okay, so this is where the geographic location is very important. Let's say the building is located at the Philippines where they have a typhoon, so you will adjust accordingly to the requirement at the location of the site. And this is the calculation table for our wind uplift. We need to have differentiate by the 3 zones, which is a zone 1, zone 2, and zone 3. Zone 1 is the middle one, which is the lower requirement for wind uplift. Zone 2 at the perimeter, the zone wind uplift requirement is higher, and the corner is the highest. So let's say the wind uplift requirement for the corner is highest, the number of fastener is required to be increased also. So for random bond system, we will practice 6 fastener per board. This board is referring to the insulation board, 4x8. At the corner area, we need to use 12 fastener per boards. So that's a way we increase the number of fastener to increase wind uplift. Okay, and on the same time, for the fixing bar, it also need to be increased accordingly to the wind uplift for that particular roof. So let's say your roof is 90 PSF pound per square foot, then we only need a fixing of 300 mm off center. Let's say your roof requirement wind uplift is 105, then you need to reduce the fastener spacing to 150. On the same time, let's say this is a metal deck. The metal deck securement to the purlin is also need to be increased. Okay, so for zone 2, the basic rule of thumb is 50% compared to the zone 1. And for the zone 3, it's 2 times compared to the zone 1. So this is a typical project we have, and we implement this type of calculation methods. Okay, so we move on to quality inspection. Quality inspection is very important for roof, especially TPO roof, because they say there's a leakage point due to the welding issue, then it will cause problem, and it is very difficult to find the root cause. So sink control test welding. So this is before we start the job in the morning, we are required the applicator to test weld and get the temperature and peel off the sample. So for OK sample, you can see the reinforcement fabrics. And this need to be tested 3 times in a day in order to make sure the machinery no issue, and also the voltage supply to the site is consistent, and the temperature will change, the environment temperature will change. In the morning it's very cool, in the afternoon it's very hot, so the welding machinery temperature need to be adjusted accordingly also. So once you do the welding, you need to test 100%, just like I mentioned before, using this equipment. We call it as a SIM probe to check any quality issue on top of the roof. For induction welding, is required to check the quality of welding, and normally it depends on the membrane thickness. So you can choose, let's say you are using a 45 mil, you can choose 45, and you choose hotter or cooler according to the environment condition. Okay. Then we go to the repair and leak detection. How to detect a roof with a leak issue on a TPO membrane roof. Oops, my font changed. Okay. OH and repair addition test is the third party, which is a SRI, conducted a test for a TPO roof in the US, and they confirmed that even a H TPO membrane roof can be performed and can be repaired accordingly, and the quality of the repair is equivalent to the new roof So let's say your client is worried about the TPO membrane roof will be damaged over the time due to the activity on top of the roof. So we can do the repair and patching, even the roof is already aged. But there's no issue about the repair job on a TPO roof. And we can do a leak detection using this moisture scanner for leak detection on top of the roof. And conventional in Malaysia is either they skip the leak detection when we hand over the project, or they do a very conventional method, which is a water ponding. Water ponding is very difficult for a large roof, especially you have a 10,000, 20,000 roof and a high pitch. Very difficult to do the water ponding test. So that's the reason we introduce a roof moisture scanner for a leak detection on top of the roof. And this machine, we also can match the moisture content to hold the roof. So when you are having a red area, so it means that that area is potentially have a leakage issue. Then you can start the investigation on that particular area. So I will show you how we are using this.
Which seem to be designed to trap as much water as possible, which then leaks steadily into the ceiling below. By following the line of least resistance, the water usually appears through cracks or holes made by the light fittings. Well, that could be lethal, but if it came straight down through the layers of the roofing felt and from directly above, then at least you'd know where it would need fixing. But oh no, instead it creeps in unseen from somewhere else in the roof and travels down between each of the layers of roofing felt till it finally finds its way down to your damp patch. So if you don't know where your leak is coming from, how can you find it? Well, you could track it down with one of these, a moisture meter. You push the probes into the relevant surface and switch on, and you get a reading there, which is the amount of electrical resistance between the positive and the negative poles. Now, apart from taking all week, the only problem here is that you're left with a roof full of holes. Now, what you really need is one of these. No, it's not a giant carpet cleaner, but a very accurate moisture detector. It uses a similar principle to the probe, except that instead of a direct current, it works on an alternating current. And that means the current can actually pass through the insulating layer, and that's called an effect called capacitance. So with this machine, the current increases when it detects water lying actually underneath the dry surface. Right, now we've made a hole somewhere in this roofing felt, and although the surface is dry, we've poured some water underneath, so we should be able to find out exactly where it's lying now. Now, it's dry there, and it's now wet here, where the bleeps have increased, and the dial is, the needle's gone right off the dial there. So move on a little bit further. And it's a little less damp there. It's come back a bit. And there's more water underneath there. And if I move right on over, we become dry again. So the water, at a fair bet, should be underneath here. Lo and behold, there we are. That's not too bad at all. Now, of course, this is the large industrial version, but how's this for the miniature version? It can easily pick up any moisture that's in my hand. Ideal for anyone in a building that's prone to springing leaks. Like Whitehall, perhaps. Good night.
So using this carpet cleaner, it make your life is much more easier to find a leak.
Okay, mining now is back in studio. You've probably by this point seen some of our footage and images from doing PAM. So it's a fun experience, but there's also something nice about being in the studio, be able to relax, walk through topics with the guests.
Okay, we go to Tpo Accessories, which is available in the markets. So let's say the applicator can use a different type of a corner accessory to terminate the detailing on top of the roof. They can choose these three type of accessories. And drain is also available using TPO membranes. So you will no need to form the membrane on top of the roof itself. They're using pre-molded accessories from the factory. Penetrations available also. And for M&E roof, architect may prefer to have a walkway, so that the walker will be walk on the designated walk area instead of walking around. So you can have a walkway on top of the roof. This all is made from TPO membranes. And for scupper drain is also that available. So this will be my last slide. So I will go through some of architecture roofing details. So this is rich details, typically rich details. And you can see that the water flow is opposite of our joint. So there's a very less risk of the water penetrations. But further, all our joint is hot welded. It's 100% in a one piece, I can say in a one piece. So there's very less likely that the roof will be leaks. So this is the roof edge details, or we call it as a downturns. So we will fold the membrane down to the roof edge and terminate it using a lip bar. This is a typical wall upturns. As I mentioned before, that anchorage is required for all the roof. So this is an anchorage point. And once we penetrate the anchorage point, we need to have one layer of membranes to seal the penetrations. So this upturn is typically 150, and it depends on customer. Let's say they want 400 or 500, then we can do accordingly. This is a raised door seal flashing, a combination in between a TPO system and a liquid system. You can see the TPO system will be here at the top area where we are using a liquid to overlap the TPO system. Expansion joint. We have a pre-molded expansion joint to be used on site. Firstly, we are recommended to have a upturn first, then followed by the expansion joint. And let's say there's the roof itself is already insulated. Of course, we need to have insulation at this area in order to avoid any thermal bridging issue. Typical pipe penetration detail using a pre-molded pre-molded TPO membranes. That's all from my side. Thank you.
Okay, thank you so much. That was very informative, very detailed, very informative. I think we'd like to do a Q&A session right now because honestly, tea will only be served at 10:30. So we're going to have a bit of a Q&A session right now with our guests. Would you like to come back on stage, please? Thank you, Mr. Lim. So let's open it up to the floor. Now, if you have a question, raise your hand. Someone will come to you with the mic. Please introduce yourself. And of course, ask your question directly to our speaker, Mr. Lim Yong Siang, today. So who would like to be the first person? The first person who asks the questions gets a special prize. The prize will be as much teh tarik as you like later. And no leaking in the cups, we promise you that.
Mr. Lim, how much should we budget for, say, a typical TPO system? So,
that is also very depend on the insulation you are. I mean that the U value, because insulation material is one of the costs for the roof. Typically, I think I need that advice from Angeline, 300 per meter square, 300 per meter square for one roof with insulation. I think we can meet the U value requirement in Malaysia, 0.4. So 0.4, 300 meters square. Of course, it depends on the skills of the project, and it can be nego the listed price.
Okay. Would you like to take a seat? No, over there. Okay. Yes. Of course, actually speaking of U value and SR value, SRI, sorry, right? Some of us in the audience might not know what those things refer to. So could you explain to the members of the audience what specifically is U value and SRI value?
U value is the thermal insulation value of the roof. So in Malaysia, UBBL requirement is for metal deck is less than 0.4, and for RC is less than 0.6. That's the requirement. And for SRI value means that SRI value means it's for the white roof. Normally we have a high SRI value. So SRI value means that it will reflect the heat from the suns compared to the black color object or black color roof. As an example, EPDM roof is a black color roof. The SRI value is very low, and it will reflect the suns. For white color roof, it will reflect, and the typical surface temperature for high SRI value roof, it will be lower compared to the EPDM black color roof. So that's a typical comparison between the TPO white roof and EPDM black color roof.
Thank you. Can we get another question from the audience? Of course, it's open to the guys up there as well. Huh? On the top floor, we will throw you the mic because we can't actually get there. But if you raise your hand, we will still find a way to talk to you. So, ladies and gentlemen, let's not be shy. We have a lot of interesting questions this morning, I'm sure. Anybody else would like to ask a question? I think someone raised the hand at the back there. No? Very shy. I think some of them are actually wondering who is brand S, to be honest. Are you wondering who brand S is? I know I am. But some things are perhaps better left unsaid. So, well, ladies and gentlemen, it's going to be a very quiet session. Then for the next half an hour, we'll be just looking at ourselves. So I would like to all of you to please, I implore, ask questions. Don't be shy. Ask questions. Okay, we have another one from the front here. He's going to get 2 teh tarik from me later.
Your typical TPO membrane, the outer layer, what's your typical SRI?
SRI. For white color membrane, typical SRI is 100. 100. It's very high compared to GBI requirement, I believe. Yes, it's way over already. And let's say architect prefer a gray color because they worry about dirty issue on top of the roof. We have a energy gray. So energy gray still can meet the minimum requirement for SRI, but it won't create an issue of aesthetic because of the dirty, because it's gray color obviously, but it still can reflect the heat. For energy gray, I think typically it will be around 70. If I'm not mistaken.
No, you made an interesting comparison just now, the idea of the industrial cooker in the induction process, right? Okay, so for some of us who only want to go to a restaurant, only makan, we have no idea what those things are. Can you explain to us what exactly that is when you say using an induction process akin to an industrial cooker rather than the typical way of fastening or welding or such?
Firstly, induction, I explain first induction cooker. So normally induction cooker, they are using electromagnet to heat up a metal cookware.
Is that like a microwave kind of?
It's not a microwave.
Okay.
It's not a microwave, but it just use a magnetic resonance to heat up a metal surface.
Right.
Okay. So once for this particular you can't use any clay type of cookware because it's not obviously it's not a metal, so it can't heat up. So it's only applicable for a metal surface. So this same concept we are using for induction welder. So it's used a magnetic, heat up the metal plate, which is the golden plate just now I showed.
Mm-hmm.
So once it's heat up the plate, the coating, the gold color coating will be melt.
Is that actual gold or is it just color only gold?
Just color only.
Oh, what a shame.
Okay. So once the plate is coating is melt, then we use a magnet to compress the TPO and the plate together.
Right.
So the magnet is also act as a heat sinks,
right,
to cool down the thing faster.
Interesting. So the application of the magnet actually excites the atoms and they heat up. Is something like that? Is that right?
Yes, yes, correct.
Okay. Very interesting. I've got a question here. Where's the question? I don't see the question, I'm sorry. Tak ada lah. Semua kata mana, I pun tak tahu. Sorry, we're looking for the question right now.
There's a question there.
Okay, we've got one question here, and I'll get back to you shortly. Yeah? May I know the product is suitable for building area the C from Mizi, I think.
Sorry again.
Oh, it disappeared again. May I know if the product is suitable building for the C by Mizi? The C, yes, that was the question. Like somewhere near the sea.
Nearby the sea.
Yeah.
It's not an issue at all. It's not an issue at all. We only need to do the wind up. Let's say just now the question is referring to the concern on the wind uplift, so we can increase the number of fastener accordingly. Let's say you are worried about a corrosion issue. Mostly all the fastener will be hide under the TPO membrane, so you won't facing any corrosion issue. For the exposed part, you use aluminum material, so you won't facing any corrosion at the upturn area or termination area.
I think someone in the audience had a question. Did someone? Yes. Can we please have that lady over there?
Hello. For retrofit, for concrete, concrete flat roof, do you need insulation as well?
Can. For retrofit concrete, it's also possible to include insulation. So once we lay the insulation, then we will fix.
Or can we take up the insulation to reduce the cost? You know?
It's also possible. Just now, Ms. Angeline got shown the Luminleads project in Penang. That particular project is laid without any insulations. Also possible. Not an issue at all.
Actually, getting back to the idea of having a building by the sea, obviously it's not an issue, but is wind a major problem in this country? I mean, typically speaking, is this something you're too concerned about, or it's pretty much okay in Malaysia? I mean, where are the most challenging areas in the country where problem for the installation of the product?
Geographic-wise, I don't think it's an issue at all. Where at the seaside or even, any areas, and we look accordingly.
And you got some the necessary, no?
We are doing the calculations. Let's say the roof itself is located at the sea, near to the sea. Then we will adjust accordingly, calculation table, and we will do the fastening, number of fastening accordingly.
And I guess mostly it's resorts, I guess? I mean, buildings by the sea, mostly resorts. Right? Okay. We've got a lively, I think we've got a question from the top, I think. It's someone at the top. Okay, yes. Yeah, you need to raise your voice, unfortunately. Okay, you can come as close to the stage as possible and introduce yourself to the audience first. Say hello. Okay, now back to our speaker.
Possible. Let's say you want to put some heavy equipment on top of the TPO roof, it's also possible. But with the condition, we put some protection layer. The protection layer can be EPDDM pads. It's also possible we are using one layer or sacrificed layer of TPO membranes, which is we tack well on that particular area. So it means that that particular TPO sacrificed layer can be removed needed. Yeah, no problem at all.
You can ask now. Share with the audience. Okay. All right. Thank you. Thank you so much. We have another question, I think, from the gentleman on top.
Can. We can put soil on top. We also can put gravel on top. With the condition we protect with a layer of geotextile. It's possible. But with condition, let's say you put soil on top, please use FLL approved membranes, so that there is no issue in terms of root penetration.
But if you do want to put soil on top, you're basically trying to do a garden, right? So I mean, you mean to say that once your product is already been installed, immediately you can put the soil and then you can start growing whatever you like, is it? I mean, there's no like special casing or protection against all that.
Once you install the roof, it depends. Okay, let's say we install the roof, and let's say 5 years later you want to change the function of the roof. Of course, let's say you want in the first place you plan to install a green roof. Of course, we will do from day one to the handover times. But let's say in this particular case, suddenly you say I want to convert the roof to a green roof. Of course, you can do so, but adding a protection layer. Example, the protection layer for our recommendation, we will use 300 GSM protection fleece. Okay, then followed by filtration layer. And also, one of the consideration you need to consider is the loading. Is it the RC roof can withstand this additional load from the soil and from the plant vegetation? That also need to be considered.
I would think weight would be an issue, isn't it? Especially after the rain.
Yes.
With all that additional water.
Yes. All the water will be stored inside the soil. There will be additional weight on top of the roof.
And your product, no problem, I suppose.
The product itself is no problem.
Great. That's really very reassuring. Thank you. Okay, can we have more questions from the audience? Sekiranya anda nak tanya soalan dalam bahasa kebangsaan pun tak jadi masalah ya.
Okay, ya, saya boleh jawab dalam bahasa Melayu juga.
Yes, dalam bahasa Malaysia pun kalau ada mana-mana orang yang ingin tanya soalan dan bertutur, yang tu pun bukan jadi masalah.
Bahasa Melayu saya lebih baik daripada bahasa Inggeris saya.
Yes. Anak jati watan. Okay, so who would like to ask the following question? I know you have questions lah. You're just too shy to ask. It's okay. We're all family here. All part of the same industry.
Need some motivation.
Yes, I agree. More teh tarik after this. That should get the ball rolling. What about students? I'm sure some of the students, some of you look like students. I'm assuming some of you are. Any questions to the more practical aspect of design rather than just theory and philosophy? No students in the house? No? Surprising. Okay. We are going to make this poor gentleman stand on stage for the next 10 minutes for no reason. No, I'm just kidding. Yes, okay, we've got a question from the back. Thank you, sir. You're a lifesaver. Please come to me later for your teh tarik.
Okay, I got a question about heat aging of the membrane. How long would it last? Durability, functional durability. I mean, how many years before we need to replace it? That's another way of putting it.
It depends on the warranty is depend on the membrane thickness. Okay, for 1.1 membrane thickness, we give a warranty of 15 years using a Reynolds system. So let's say you increase the membrane thickness, it will give you longer warranties. So at the same time, I can say that the thicker the membrane is more durable against the weathering issue. Example is UV or heat. And one of the advantage for TPO membrane is, let's say your roof is facing water pondings, and once the water ponding is there, and the sun is heat up the water, and it will cause much more faster degradations. But for TPO system is designed to be more durable in these situations compared to PVC membranes. So I can say that, firstly, to answer your question, depend on the thickness. The thicker the membrane is, it gives you longer warranties because of the material, thicker materials. So that's the straightforward answer for your question. And of course, we did all the evaluation. Just now I shown before. Wait now. This way. Okay.
Lots of slides.
Yeah. So this is the heat aging test. Standard is the 32 weeks, but for our 1.14 for 45 mil thickness, it can last for 60 weeks. This is an acceleration test, so it's not directly translate to 60 weeks only your membrane will be last. So we can give you 15 years warranty for 45 mil TPO membranes using a random bond system. Okay.
Oh, there's another question there for the lady.
Mil is in US units. US units. Yeah, I foresee there's a question about mils, so I already convert to mm. So you can see 45 mil is around 1.14 mm.
So mil is a unit of measurement they use in the US.
Yes, correct. Since our product is made in the US,
right.
So that's the reason we still maintain a 45 mil.
Okay. There's a question from the top. Okay, please say hello to the audience and.
Firstly, just like Angeline got mentioned before, we have warranty programs. So once we hand over the project to the clients, so we will engage with the client on the warranty programs and the maintenance programs. So normally for new project, we'll give 2 years free in terms of maintenance. So after 2 years, the client need to continue with the maintenance programs. And let's say they follow the maintenance program, then we will give them the 15 years warranty. If not, you based on the purely product warranty, which is 10 years. So the reason that we require a maintenance program is we want to ensure that the roof is not, how to say, so we don't know what is the activity on top of the roof over the years. So that's the reason we need to understand and we need to check every year. And for all that, because for the upturns, we also have a sealants, which we use. And the sealant obviously won't last for 15 years. So I check out 15 years for the sealant warranty, so I Tpo you lah. So that is fall under maintenance. Okay, that is fall under maintenance. So that's the reason we want to make this program a compulsory in order to give you the full 15 years warranty or 25 years warranty, because there's a lot of things happen on top of the roof, especially after storm. So let's say after storm, we encourage the customer or the client to call us and go check, so we can understand what happened on top of the roof and we can do the immediate repair.
Assume that the program need to be carried out by your panel specialist, so to speak. What would be the cost like for that?
What will be the cost wise? It's very depend on the build out of the roof, and we will advise accordingly to the clients. Can be few thousand for one roof, and it can be cheaper. Let's say the roof size is bigger, but it will be based on per meter square, obviously.
Okay, thank you. I think we'll take a couple of last questions. Does anyone else from the audience have a question? There's one gentleman at the back there.
Hi, thank you. Just a question here regarding the ease of maintenance or perhaps replacement of your system. Can you perhaps review anything about that? Basically the roof at the end of its service life. What sort of thing can we do about it?
End of service life means that, let's say we give you 15 years warranty. So once at the 16 years, what will happen to the roof? Okay, there's two scenarios. One scenario, the whole roof need to be replaced, and we need to tear off the whole roof. And this material is a recyclable materials. In the US, they have a recycle program for TPO roof. So all this can be recycled and it's not required to dump into the landfill. So that is one of the advantage. So let's say the condition of the roof is still okay. You can do repair. Just now I got share about the repair report by SRI. So we still can do the repair job on top of the roof. It means that let's say you have one area which is already having some puncture issue on that particular area, so you can patch it with a new sheet of Tpo membrane on that particular areas.
Okay, thank you. What's been your most challenging project so far?
Most challenging project so far is Pfizer in Singapore.
Right.
Okay. The reason is they have a lot of penetration on top of the roof, and so that's the main challenge now for that particular area.
Okay. Ladies and gentlemen, I think we'll take one last question and then I can break for the tea break. So who would like? Okay, we've got one gentleman over there.
Hi. Your warranty is a product warranty only, or is a product and workmanship warranty?
It's a product plus workmanship.
I hope you have a project for him.
Thank you.
Of course, yes, you're more than welcome to talk to our guest speaker during the tea break in case there's any more questions you'd like to ask in private. But then, of course, it can be conducted later on your own time.
Thank you.
Okay. Okay, let me just check and see. Are we ready for the tea break? We are? Okay, great. So that's nice to know we're on time for that, as usual. When it comes to makan, we're never late. Well, you know, occasionally lah. Huh? So, ladies and gentlemen, let's give a round of applause to our guest. Now, before you leave for the tea break, a couple of announcements. First and foremost, thank you again for being here. Now, to comply with the COVID-19 safety measures, the refreshments will be served at 2 different places. Now, those 2 different places, we are going to leave it to you. You can find where it is. It's somewhere in the building. If you decide to go and hunt on your own, that's up to you lah. Okay? Kidding. One is, of course, on the rooftop, and the other is on level 1. So, we would advise you to please separate and go to these places on your own. Those in the auditorium, please proceed to level 1 or the rooftop at level 8, and the refreshments are served in both areas. The session will continue at 11 a.m. in about half an hour from now, and we've got something really cool to mention to you. Literally, the topic, of course, is green buildings are cooler, literally. So, at 11 o'clock, we're in a Masters in Architecture with Distinction, VUW in 1985. Now, he was a past president of PAM, and has been serving in PAM in the council since 2004, and has served as a PAM representative in various committees, in CIDB, KPKT, KETTHA, CIRIM, and a lot more letters after that. Without further ado, his title, of course, for today is called Green Buildings Are Cooler, which are, of course, a review of the UBBL Bylaw 38 and designing roof insulation and building envelopes for BL 38A compliance. I'd like to call upon Architect Chan Seong to come on to the stage to present with us his presentation. Thank you.
Of the mask. No, not to worry. Okay, this morning I think is I'm going to touch about what are the aspects of buildings which are going to be influenced by the architect himself lah. Okay, so maybe we start with the first quotation from Dr. Ken Yang. He's the grandfather of the building revolution in Malaysia. So designing to respond to climate is the first aspect of green building design. That's one of the key things that you remember. Okay, so designing the tropics, architects depend on. I think I also do design based on intuition, but our intuition has got its limitations lah. So you need to benchmark your design in terms of how much heat actually goes into your building. Okay, that's very important because you are designing a building in a tropical climate. Heat is one of your biggest issues that you have to deal with. Okay, so bylaw 38A of the UBBL is the first thing I want to talk about first. Now, bylaw 38A has already been in the 2012 already. The version has been incorporated. No, sir. Okay. So this the latest amendment to the UBBL, which is the 2021 version, has already got this entrenched into it already. So the energy efficiency requirements are in there. So if you are renovating a non-residential building with air conditioning space more than 4,000 square meter, you have to comply with these two requirements. Okay, designing to meet the requirements of MS 1525 in terms of your OTTV and your roof insulation value. And then you have to provide an energy management system. Now, earlier attempts to put this requirement into the bylaw before 2012 didn't go through because they took the entire standard and tried to shove it into the standard, into the bylaw, and our parliamentarians being the people they are, they still cannot understand. So they say architect also cannot understand. So never mind. So what they did is they didn't pass it until we reduced it to a minimum of these two. So what are the key things that we need to remember? It applies to non-residential building if you are aircon. If it's you have to have the OTTV not more than 50. Okay. For architects and engineers, they must submit the OTTV and RTTV calculations for all buildings. That means if you are doing any building under bylaw 38A, if it's a new building or renovating building, you have to follow this bylaw already. This is inside the standard. Okay. Now, unfortunately, in Malaysia, we have a multi-layer, legal system. At the top of the legal system is our UBBL. This is a federal law. Okay. Now, federal law doesn't apply into the state until it's gazetted into the state law. Okay. So in this particular case, bylaw 38A, many of the states are still dragging their feet. Okay. They do not include that into the bylaw. So to date, as far as I know, only 4 states have included it and gazetted into their state bylaws. These states are, the former opposition control states, Penang, Kedah, Selangor, and Terengganu. Those are the only 4 states which have gazetted it. And the only 2 states have actively started to enforce this requirement. Penang especially, I think if you are working in Penang, if you submit your building plan, they require you to submit the OTTV value and the roof view value also. Okay, so this is a bylaw requirement. That means it's already entrenched into the law for quite some time already. Okay, so we have to understand what actually building envelope is. It's the external portion of the building throughout which the energy transfer happens. And then the major factors affecting interior thermal comfort and the energy usage is how much heat goes into your building. Okay, so we have to understand some basic physics. So thermal conductivity is how fast the heat goes into your building. Okay, so how fast the heat goes into your building depends on 2 things. Or if you want to include the area, of course, 3 things. The first is how thick the material is and how well the heat goes through the material. So if you're taking, like for example, if you're taking say if you're using a metal deck for your cladding, the heat will just go right through it because heat is metal is a good conductor. Whereas if you're using, for example, brickwork, the heat goes in slower. Okay, because the thermal conductivity is higher. So if you double the thickness of the wall, you actually double the thermal conductivity. Reduce the thermal conductivity by half. Okay, so what are the areas whereby heat go into your building? Depends on which type of building, Of course, if you are talking about, for example, buildings like, never mind, the single-story terrace houses, typically 70% of the heat goes in through your roof. Whereas if you are doing a double-story terrace house, about 50% goes in through your roof. And then if you are doing, apartments, 4-story and above, or slightly below that, most of the heat actually 40% goes in through your roof. So you can see, yes, this morning's lecture talk about, not only waterproofing, but he also include the insulation layer inside there. These are the ones that influence whether or not how much heat go into your building. Okay, very important, that one. Okay, but if you are doing high-rise buildings, commercial buildings or factories, the envelope itself, they call it the building envelope. That is not including the roof, all the rest of the building envelope. If you look at factories, single-story factories, only about 25% go into the walls. Low-rise office buildings, about 60%, just like just now the apartment. And then if you are looking at high-rise apartments or high-rise office buildings, 80% of the heat actually goes in through your elevation or your envelope. Why? Because the area is much bigger. As simple as that. The area is much bigger. Okay. Now, if you look at the thermal resistance, let's say of a typical terrace house sort of environment, this one is if you look at a single-story terrace, depending on which direction you're facing, you see if you are facing north-south, your double-story terrace, the heat gain through your walls and envelopes about 55%. Compared to if you are east-west, you're talking about 73% coming in through roof. So depending on which direction your building is facing, you have different amount of heat gain. So this one I think is put in because I understand quite a lot of us are still doing housing, especially if you're not in the Klang Valley. Landed housing is still a very important part of our portfolio. Okay. So in summary, OTTV applies for building envelope, and our OTTV, our overall thermal transfer value, cannot exceed 50 watts per meter square. Okay. And then our roof view value, if you are using a lightweight roof like a metal deck roof, you cannot exceed 0.4 watts per meter squared. And then if you are doing a heavyweight roof like the concrete roof that Mr. Lim showed you just now, you cannot exceed 0.6. Okay. Now RTTV only applies if you are doing, for example, buildings which have got skylights. If you are doing a lot of buildings which have, for example, like warehouses and factories, you need to put in, if you need to put in the skylights, typically you have to calculate the RTTV value or roof thermal transfer value. Okay, so this one is 25 watts per meter squared. Okay, let's look at the OTTV for building envelope. Now, I'm not going to be able to cover the full scope of how we calculate the OTTV value, but maybe can I have a show of hands? How many of you in this group, among you architects, don't know how to use Excel, Microsoft Excel? Any of you? So everybody know how to use Microsoft Excel. That's good because OTTV calculation depends very heavily on the use of Microsoft Excel. Okay, why I say that? Because Microsoft Excel allows you to input the values that you want to calculate instead of using a calculator, and then you can start to evaluate what if I put in more this and more that, or I put more insulation, or I reorientate my roof. Because without that, you as a designer, as an architect of the project, you have no control over it. A lot of times in the early years, maybe 10 years ago when we first started to introduce that into the UBBL, a lot of architects just refuse to do the calculation. They just say, give it to the M&E engineer. And that's, creates a lot of problem for the building, because then that's why we started the Green Building Index and started to train a lot of architects on how to calculate OTTV. Okay, so the passive design strategies usually first is to orientate the building. Okay, just now I showed you different orientation, get different. But sometimes this sort of thing you have little control over it because your site is already in that particular orientation. Now the other ways of doing it are you to shade the building, you insulate the building, or you ventilate and dilate the building. All these are affected by the building envelope. Okay. Now again, I come back to the three key factors affecting how much heat go into your building in terms of material only. The first is the thermal conductivity. So if you want less heat to go in, you have to use more insulation material. And where is the heat coming in? If it's at the roof, you got to put more insulation on the roof. Okay. And the thickness of the material and the thermal property of the material. Three, or the fourth one maybe you talk about the area of the material. Okay. Ottv applies to the building envelope. The roof value is calculated on the thermal transmittance, and then RTTV is on. So these are the clauses inside the contract, inside the standard. The design criteria for the building envelope overall thermal transfer value has been adopted. And what does the OTTV stand for? Okay, some of the assumptions based on the OTTV are internal shading devices such as curtains are normally not included, because by the time you include the curtain, inside curtain, the heat already gone into your building. It will be absorbed by the curtain and then re-radiate back outside. Solar reflection or shading from adjacent buildings is also not included. And currently green walls also we don't include. Okay, because sometimes the thing might not grow or might be removed sometime later. Okay. So the formula for calculating the OTTV is usually consists of three components. The first is the heat conduction through the wall. The second is the heat conduction through the windows. And finally, the direct solar gain going in through your building through your windows. Okay, so there are three components in there. The first component normally, if you are talking about heat transfer into your building, is very small, about maybe 1 to 5% only. So that's why sometimes if you're doing like terrace houses or you're doing high-rise apartment, don't focus on the wall. Focus on the window, the glass. Okay. The second one is heat conduction through the glass itself, the windows. Okay. This one is typically between 10 to 20% of the heat gain through your envelope. The third one is the biggest. Solar heat gain through the windows is normally between 70 to 80%. So which are the one that you want to focus on? You are doing design, always focus on the one with the biggest factor, 80%. If I reduce that by half, I can reduce by heat gain by half already. So it's, by 80%, I can reduce the window heat gain by 50%. I'm reducing the total heat gain by 40% already. So don't forget, important focus on where the heat going in. So in the one later on, I will talk to you about okay, now, since a lot of you have know how to use Excel, I'll just go through a quick example. This is Menara UAC, quite an old building, more than 12 to 15 years old already. This was taken as an example by architect Wong when he was working with me for the GBI, what they call it, lectures. So typically the building has got all four sides glass, okay? So, how you calculate is actually taking the window area. The window area is called the window to wall ratio. So like I said earlier, how much heat go into your building depends on how much glass you have there also. The fourth factor, which is the area of glass. That affects what is known the window to wall ratio. The more glass you have, the more heat goes in, correct or not? And then the 80% one will become 90% already. So typically a building like this, if you have with full glass, the OTTV will easily shoot up to between 80 to 100 watts per meter square. Okay? And a lot of old office buildings, both in the Klang Valley and throughout the Putrajaya area, the older ones typically have OTTV of up to 80 to 100. Okay? And then they are now beginning to start to refurbish them already. Okay? So your heat conduction through this type of tables, I think if you want to use the table, the Excel table, you can download it from the Green Building Index website, or later on you can ask one of the staff here. I will pass you a copy. You can take the Excel and then you can input the data yourself, and then you can see. It's very simple. You just calculate how much window area, how much wall area, what is your property of your wall, and you can start to generate the figures already. So for example, that just now the first one was the heat conduction to the walls. Then the next one, you look at the heat conduction through the windows. And then finally, you hit how much solar heat gain directly goes into your glass, into your building. So these are the things that you need to be able to calculate. Why do you need to calculate? Because sometimes you just build on intuition. I got, 10 windows and how many square feet, you do not know. So this figure gives you the average figure. Now, why is OTTV calculation important? Because there are a lot of engineers out there who say, oh, I can use my building simulation, simulate how much heat goes in from this hour to this hour to this hour. That doesn't give you the figure. How much use can it? Because different season, different hour, different different orientation, all got different answer one. Why is the OTTV being used by architects? Because this calculation, the figures are for Malaysia, number one. Number two, they are the average heat gain throughout the year. Okay, not just 1 minute or 1 hour or with this orientation, that orientation. Different orientation for the whole year, the average for the whole year for Malaysian weather. So that's very important why we use the OTTV calculations. So when you combine the three, you get the total figure below here. Okay. Now that building, I think 51 didn't quite make it. Now I'm going to focus on looking at the solar heat gains from the windows and how you can actually prevent heat from going directly into your building and then heating up the building and making a air conditioning load very, very high. Okay. Now, this is the factor that you look at. Okay. Now, in the calculation of the solar heat gain through the window, you can see the constant itself is very, very high. Okay. If you go back to the old one, okay, this figure here, now the early one. This one here, okay, there's no formula here, sorry. If you go back to the formula on this one here, you will see that the constant is the one that's very high. 194 is for Malaysia only. Malaysia only. If you go to a different country, that 194 will be different. If you go to Singapore, their weather conditions are different. You go to Brunei, that figure also different. Now, if you look at the constants for the other one, the CF actually is the orientation factor. Window to wall ratio is how many square feet of window you have on the wall. Okay. Finally, the shading coefficient. How many square feet of window you have on the wall? How much shading coefficient you have? That means how good is your heat yielding for the building are reflected in numbers in there. Okay. So this is a way you can actually estimate how much heat go into your building. Okay. So you can see 194 is the constant for Malaysia. The correction factor or the orientation factor. So different orientation, different amount of heat. I think you also understand why. Then the window to wall ratio is how many square meter of glass you have on each orientation. Okay. Then the shading coefficient, I will talk to you about it after the following slides. So the orientation, of course, is in table 4 of the standard itself. East orientation is normally the higher than the west orientation. Okay. Now, the solar heat gain through the windows, normally they consist of a few components, like you have UV, you have infrared, and you have the visible. 3 components you have to watch out for. Okay. So if the solar radiation is using normal glass, some of it is reflected out, some is transmitted in, some is absorbed and re-radiated inside. Okay. Now, the first factor you got to do for shading coefficient is look at the glass properties. Okay, the glass shading coefficient. Normally, if older buildings, if you look at many older buildings, if you want to refurbish the building, you got to look out, find out what is the shading coefficient of the glass. Now, in the earlier days, many of the buildings, they use total clear glass, or a shading coefficient of 0.8 or something like that. That means 80% of the heat goes in to the building. Whereas later on, they started to adopt what they call tinted glass. Okay, tinted glass normally shading coefficients are about 0.6. The disadvantage of tinted glass is, even though it allows only 60% of the heat in, it also blocks out 60% of the light. Sorry, allow only 60% of the light in. It blocks out 40% of the light. So in an office building, a lot of times you want to use the lighting from daylight, because daylight is the best quality and free also. Okay, so this is why shading coefficient is important for you selecting the glass. So the glass, you got to look out for two things, two properties always when you specify glass. The first thing is the shading coefficient. Okay, just now I told you the shading coefficient is actually a reflection of how much heat go into your glass, So if the SC value of the glass is 0.6, it means 60% of heat is going in through the glass. Okay. The other one you got to look for is the visible light transmittance. Like I said earlier, if you are using tinted glass, typically the shading coefficient is 0.6 to 0.7, but the heat that's the heat being reflected away, blocked out. And then the visible light transmittance is also about 0.6. That means only 60% of the light go in. Then sometimes if you look from the inside of the building, looks a bit gloomy. And people don't like gloomy buildings. They make them like the building. Okay. Then the insulated IGU, where you have multiple planes of glass. These are the new ways of addressing the building. But in Malaysia, unless you are going for very high value buildings, you wouldn't normally use IGUs, insulated glass units. These are the double glazing one. Why? The reason is quite simple. You look at the formula I give you earlier on. Heat going in through the walls, the glass is 5%, 10 to 15 or 20%. Now, the insulation value of the glass, you are only attending 20%, whereas the other is 80%, or close to 70 to 80%. So why would you want to go and attack the center one, which is the double glazing? Okay, a lot of people try to use thick, heavy glass because they think it gives you the insulation value, but it doesn't. That is only about 20 to 30% at most. Double glazing also give you 20 to 30% insulation. So if you I reduce that by half by putting double layer glass. That 20% you only reduce by 10% of the heat gain. Whereas if the other one is 80%, you reduce by half, you're reducing 40%. Okay? So always focus on the SC value of the glass. Don't worry about the insulation value or how thick the glass is or how much. The one thickness is depend on safety factor, of course, not the one. So IGUs can be further improved by tinting the glass, coating the glass, and low emissivity glass. Okay, so that one I won't go into detail. So these are the typical ones. The air gap is the one that actually prevents the heat from going in. So if you are going for a very high value building, for example, multi-story hotel or multi-story office, whereby you're already pushing everything to the limit, then the double glazing become very important because the heat gain from the window already reduced to up to 30% of the heat going in. Typically in a double glazed building, the SC value is as high as 0.3. The only 30% of the heat is going in through the glass. Okay, the direct heat gain. Whereas the remainder will be still at 20%. So that's where the 20 and 30, and then you can put in the double glazing. So very important, remember, if you are doing a high-rise building, unless your building is going for a very high performance building, there's little reason for you to go for double glazing. Okay, so if you are doing, for example, high-rise apartments, you wouldn't want to go for double glazing. It's better to do either external shading or you do a very good SC value glass. Don't go for double glazing. Okay, so typical sun shading are the ones that affect what is known as the SC2 value. That one glass is SC1 value. SC2 is where you can, the architects have control over how well shaded your building or your glass is. Okay, typically like this, these are the sunshades that you would apply, say in a commercial building, and these are the ones that give you the additional shading coefficient that you want. Okay, so let's say, for example, these are the external shading that we are talking about. Now, how do you actually look at the shading coefficient? This is the shading coefficient you use. R1 value. R1 value is how much the horizontal projection is against the height of the window. So this is how you calculate. And then if you look at the tables given in the MS standard itself, that will tell you how much shading coefficient according to the direction. Okay. So the shading coefficient, the total shading coefficient for typical windows, that means how much heat goes in, is the multiplication of S1 times S2. Okay, so for example, if you're looking at this one, if your ratio just now R1 is about say like 0.5, and then you are in the north-south orientation, the shading element itself is blocking out 30% of your heat going into your building. If you got another 0.3, let's say your shading coefficient of glass is 0.3, so 0.3 times 3, 0.3 times 0.3, the shading coefficient then becomes 0.9 already, so which is very good already. So this is the way you can combine the two shading coefficients to actually keep your building cooler. So this is the way to calculate the two things. Okay. So typically you can see depending on the SC, what they call it, the ratio that you have, the R1 value, it begins to drop off, and then as you put more and more in, longer and longer shading, it begins to drop off, and there's not much value anymore. So this is for the horizontal projections. Then there's some for the, so typically this is the one they can see. So this one is calculated not for any moment in time, but average out throughout the year. So if you go back to this one here, this figure are actually the shading coefficient for the window orientation and the different projection, average out throughout the year. Okay, this is throughout the year. So that you can use the figure, estimate how valuable is your shading element itself. Okay, and these are the R1 values that you can see. Okay, this is the, you can see when you start to break up the thing, the R1 value starts to go up also. Instead of one big one, you can break it up into smaller ones. Okay, typical would be like, for example, the PAM building itself, you can see it's an egg-crate sort of design. So the thing is broken into smaller values. So that will give you a better shading coefficient compared to one big element coming out. So of course there is different type of design. You as the architect have total control over it. This one, the big one, maybe is your, for example, if you're doing double-story terrace, that would be the, how they call it, the garage or the balcony for the building. Okay. Okay, the other shading coefficient you got to look at is the vertical shading coefficient. Okay, vertical elements. Vertical elements are in the tropical climate is less effective than horizontal elements. What is the reason? Because our sun path is very high. Whether or not it's winter or summer, it's only a slight difference in the angle. Our sun path is very high. Okay, it tends to go up very high and then it comes down at a different angle. That's why the shading coefficient for the horizontal elements, you can see are very much higher one. Okay, the shading coefficient just now I show you. Okay, this one here you can see the SC can go down as low as 0.55. That means only 55% of the heat go into the building if you correctly put in the type of shading elements that you want. So if you're say for example, if you're having a glass shading coefficient of 0.5, shading coefficient of 0.55, only 25% of the heat is going in through your roof, through your glass window. Okay, so that is a very effective way of shielding out the heat from going into your building. Okay, and then you can put a number to it also. So when you calculate the entire building's shading coefficient and you put it into the Ottv value, you can compare one type of design to another type of design, and that you can actually tell your client, okay, my Ottv is 0.40 compared to the other one, 45 or 40 or 35 compared to the other one 80. So he can then understand why one building is better than the other, because you can see the numbers. 80 watts per meter squared is a lot of heat going into the building. Compared to a well-designed building, the Ottv can be as low as 30, 35. Okay, so this is the very important factor you need to convince them in the tropics. Okay, shading coefficient projection for vertical elements. Okay, I can see the angle just now, the shading element just now, the one here. It's much steeper, can go down as low as 0.55 also. Okay, whereas if you go to the vertical ones, the most we can get to is 0.7 only. Okay, so depending on how close you put the vertical elements, it will affect the shading coefficient of your elements that you put, your design elements you put into your building. Okay, so when you combine all these numbers together, you can get your overall thermal transfer value of your building. Okay, so how do you improve the OTTV or overall thermal transfer value, which is the envelope's heat gain? One way is to identify the components which contribute the most to the OTTV. Typically, the glass of the building. Okay, you already know 80% of heat going to the glass. You have to review the solar correction factor, or in the table 4, or the orientation factor. Now the new definition, orientation, OF. You have to look at the glass that you're using. Okay, the better the quality of the glass, higher the shading coefficient value. That means SC will be typically below 0.5. It will be 0.3 or 0.4. But the VLT, or the visual transmission, VLT, visual light transmittance value, can be as high as 0.5 or 0.6 compared to the SC value of 0.3. Okay, so that is a good quality glass. The poor quality glass, like tinted glass and all, the SC value and VLT is about the same. Okay, just remember that one. Then you have to review the sun shading or external SC values, which is what you can design for your buildings accordingly. Okay, then you review your window to wall ratio. Okay, what is window to wall ratio? That means, remember I told you heat gain into your building, the fourth factor is how much area there is. For example, if you are dealing with glass, a whole full glass building, you're doing a commercial office building or commercial building, owner insists must be full glass. So how do you actually reduce the glass area? You cannot do it, isn't it? Typically, if you invite a European architect to come in, he doesn't know anything about OTTV. He will use a simulation program, and then you say, oh, okay, this is how it is. We cannot do anything more. Whereas an architect trained in tropical design or in Malaysia, typically even if you are a glass building, you can still block off some of the glass window. For example, typically from the floor level until about 0.8 meter or 1 meter, the one it doesn't contribute to your daylighting into the building, because you don't work on the floor, you work on the table typically, isn't it? So anything below that, the daylight is of no value. But the heat gain is still there. So a lot of refurbished buildings, we put in a parapet wall just on above the floor, 0.8 meter. So that way we reduce the amount of glass that is already. So that one, the bottom portion then is, although it's glass, it is actually calculated as a wall already. Because what we do is we seal it at the parapet level. There's a mullion there, you can seal it off, put in the insulation, and then also helps you to reduce your fire rating also, okay? Because the fire gap is improved, okay? So that was one of the ways that you can actually reduce the amount of heat going in, because then you reduce the window to wall ratio. That means the amount of glass already. So if you have, for example, typical 3 meter high wall, wall to wall 3 or 3.5, if you take out 1 meter already, you reduce by 1/3 already the amount of glass you have already. Okay, this is one way of reducing if you are doing office buildings. Okay, now this is the one that you need to look at also, calculation for concrete roofs. Now I'm going to focus on roofs now. There are two types, very common in Malaysia: concrete roofs, and then the lightweight roofs, the metal deck roofs, and then the concrete roofs. Why are we looking at this? Because these are the area where most of the heat is coming in. Remember I show you the one, depending on the type of building you are looking at. If you are looking at, let's say, buildings up to 4-story, typically between 40 to 70% of the heat go in through your roof. So this is where you need to reduce the amount of heat. So if there's a big area one, you have to reduce the amount of heat. And in a concrete roof or in a whatever roof you're doing, there's very little you can do about the area already. So you have to introduce what is known as insulation into the roof, which is what just now Mr. Lim has been talking about. I was very worried what he was going to talk about just now. But I asked for the slides that they were doing so that we don't conflict each other. I say one thing, he say another thing. Okay, so The U value of the roof is very important because it prevents the heat from going directly into your building. Especially if you are doing like single story, factories, very common in Malaysia. Okay, single story factories, they are all over the place. So I'll give you an example now. I'll concentrate on the concrete roof for concrete roof first, then we go back to the metal deck roof, because a lot of industry, they are using metal deck roof because of long span. Okay, concrete roof, I give you one example. This one is a building, is a refurbishment of the Masjid Diraja Sultan Sulaiman in Klang. Okay, this one was this project was undertaken by JKR Wilayah. Now I was involved in this because Architect Center asked me to investigate this one, because they were employed by the contractor for the project. The roof was leaking all over the place. Okay, the original roof. So I went in before they started. This is the roof plan itself. You can see if I go back. Okay, this is the roof. Okay, if you look at the center portion, you can see that's the one with the dome. The annex and all is added in at a different time. So during prayer on Friday afternoon, all that concrete roof at the side there. If you look at the old design, it's really, really hot now. Okay, this is the section of the building itself. So this is the measurement I did for the roof insulation. This one I was checking for leakage. Okay, you see on the left side one, one on the left, that one, that was before they went in to repair the roof. Now you can see the green layer by layer. Those layers actually are the external beams, very thick beams. That's why there's less heat coming in. Now you notice the temperature at the roof there at the time when I measured it, 35.7, nearly 36 degrees centigrade. Okay, 36 degrees centigrade. This one is using infrared camera. The one on the right was done after they have completed in insulation also. So they added in about 100 millimeter of, I think, high density polystyrene. So you can see the temperature difference I can see is 35 or 36, 30 temperature difference. This one from insulation is of course the normal picture, black and white picture. So similarly, in another part of the building, you can see as 37, 30. So there is a significant temperature difference from just simply insulating your roof. Okay, concrete roof is very important. Now, this is the external view. You can see this one is about 57, 54. I think that was not the afternoon, around about 11 in the afternoon, in the morning already. 54, 50. You can see, these are the type of temperatures we see even in Singapore. This one is very comparable to the temperatures that we get measured by Dr. Wong of National University of Singapore. His paper, when we started looking at it back in 2011, 2010, also yielded the same type of results. Okay, so when we started to measure this, we can see the difference. You can see just now earlier on I talked to you about those beams. You can see here, all those concrete beams. Below the beams, because of the thickness of the concrete, the green layers start coming out. Okay, so this is the difference. Okay, these are the measured results. So for RC roof insulation, typically what can we do? If you look at the concrete roof, if you just leave it alone and don't do anything, the U value comes to about 2.7 something. You can see even with the 150 mm roof. So heat just goes right into the building through your roof. This is where it's important, like you said, the waterproof membrane they also put in the insulation value, because without the insulation, just waterproofing is not much value to the building. Okay. Now, when you start to introduce insulation, let's say this one is about 50 mm of insulation, straight away you can see the Ottv value. Sorry, the roof U value drops to about 0.537, which is below 0.6. Okay, I think if you talk to Mr. Lim later on, a lot of buildings right now are refurbishment already. Okay, I doing with the, architects do another building, which office building lah, of course. They want to get certification. So the first criteria is reduce the heat gain. So they are going to start to insulate the roof. I told them, you want to insulate the roof, you might as well also improve the waterproofing. The building's already 15 years old, 10 to 15 years old already. So it's important when you refurbish, put in your insulation. Because earlier on, 10 years ago, a lot of architects don't know what is the meaning of OTTV. They do not know what is U value of roof. Now you know, you have to start doing it already. Okay, it's inside the bylaw already anyway. Okay, so typically, for example, the concrete roof, your insulation value must be, if you calculate over, if you don't put any insulation, typically you can get about U value of 2.93 like that. So this cannot beat bylaw requirement. Okay, so but the minute you put in the insulation, you can see you can start to drop it down quite a lot. Okay, typically, how much insulation is enough and how much is not enough. So this one is the value of the roof value of the watts per meter squared compared to the thickness. So around about 70 is the limit. You don't want to go more than that lah. Okay, thicker also can lah, but decreasing value of return for you. Okay. Okay. Now this one is quite new. This is introduced only about 2 to 3 years ago. Now, a lot of lightweight roof, lightweight roof includes, terrace houses, factories with metal deck roof and all that. The calculation of the U value of the roof depends very much on the value of the foil insulation that you're using. A lot of buildings, they like to use the metal foil together with a layer of let's say rock wool or something like that, and then they put a chicken wire mesh over it. Okay, so this is the typical type of insulation they would use on lightweight roof. Okay, now before I go on to this lightweight roof, maybe we talk a bit about this heavyweight roof. Now a lot of owners, I've seen many owners lah. Our biggest headache is actually not from the owner itself, but from the architects themselves. I've seen one project whereby, brand new project, the architect recommend to the owner, let's put the insulation under the concrete roof. That's not a good idea. Why? It's a brand new building. Why are you putting the insulation under the roof? Because when you put it under the roof, what happens is the heat is absorbed by your concrete roof. A lot of time there is a heat leaking in through the beams. Okay? The beams. Concrete roof have a lot of beams and checkered beams all over the place. So the heat goes in through the roof, concrete roof, and then through your beam, with no insulation, it goes right into your top floor again. So it's a problem. Then when you ask the architect, hey, why you put the insulation inside? Why don't you put it outside? Oh, the insulation always causes leakage. That's the type of excuse they give, So sometimes it's the headache is come from the architect, not from the owner itself. They misunderstand difference between insulation and heat insulation and thermal insulation and waterproofing. There are two different functions. Okay. Okay. Let's go on to the. This one is actually this one. This the foundation for doing the RSI tables. Which came out about 3 years ago, actually started when Green Building Index wanted to get some figures for the, for the roof. Like for example, typical terrace houses or factories. How effective is the foil insulation? How effective is the different type insulation on a typical tropical roof? We didn't have any data. Actually, architect went down to Singapore to meet up with Singapore's BCA and even their universities. Ask them where they got the data from to input the data for the calculation of the roof value, U values. They say we took it from the calculation, the research done by Monier. Now, Monia has got one Dr. Nigel who did a lot of research on heat gain through roof. And then he also studied a lot of things like, how lasting is the roof membrane, how good is the tiles, how lasting is all those things. Unfortunately, a lot of his measurement he did in Rome, Italy. Okay? Italy's weather is Mediterranean weather, Malaysian weather is tropical weather. You cannot take one from that side and come to Malaysia and say, oh, this is the value we can use. Okay? So what happens is, we are stuck with the data from Rome for many, many years. From 2010 and to 2015, about around 2015. That's where the Green Building Index started to fund the research. This one is done by UKM. UKM have a unit, a research unit, which GBI funded the research for doing the research on reflective insulation and also looking at how much heat actually go in through the roof. Okay, so this is some of the things that they funded. Now they funded the purchase of a machine called a heat flow meter. Okay, now in the old days until this year, we used to measure heat flow through the roof material by using, they call it hot plate method. There's hot plate at the top, hot plate at the bottom. You put your insulation material or whether roofing or whatever, and then you heat up the top, and then you measure at the bottom how much heat goes through. Okay. The problem with that is it took nearly 6-7 hours for the thing to stabilize before you can extract the value. Okay. So this is where the research costs shoot up through the sky, measurement costs shoot up through the sky. Whereas a heat flow meter, you can stabilize within less than 1 hour. Okay, so this is when you can do a lot of measurements. So this is purchase. This heat flow meter was costing about 250,000 actually, just a meter alone. Okay, this one was purchased by UKM as part of their research grant. So they put in the thing and they started to measure. So in order to confirm this type of measurement, they also have to go and measure all sort of material. So this is where you can see for different type of thickness, different air gaps, the figure actually doesn't go up and up and up. It peaks at about 75-80 millimeter to start to drop. Okay. Now, if we use the Singapore model, a lot of Singapore consultants come to Malaysia and tell, oh, we use 150 mm air gap. Therefore, we multiply the thermal resistance of the air by 150. Therefore, you give me the value of the thermal resistance. Of course, they got very, very high value, but doesn't make how do you call it, scientific sense. This is where we have to depend on measured value to come back to the table. Okay, this is where we started to adopt it. You can see at 150, around 100 like that, start to drop the thermal insulation value. Why? Because air current start to coming in already. Okay, so in addition to the heat flow meter, they also do field evaluation. That means they set up these little huts whereby they measure the different type of heat going into the building. Okay, one will be a standard one, no insulation. Then the next one got insulation. Then the next one. So they monitor and measure this one, compare the values that are measured against those with the heat flow meter, and come out with the values. Okay, these are some of the measurements done. This is also under Dr. Lim of UKM. So based on that one, they came out with known as the RSI table for enclosed air spaces. Now, the value of the foil insulation in a lightweight roof doesn't depend on the foil itself, because the foil got no insulation value. Okay, the insulation value comes from the air gap between the foil and no foil. Okay, this is where the measurement come out from Dr. Lim's one, and these are the tables which are available. Now, these tables are also available in the GBI website. Again, if you want it, you can get it from PAM staff. Later on, I will give it to them. This is important because it tells you where you can start to take the values. You can see it at a different angle. This the left side is the angle of the roof. Top is how thick it is, and then the RSI value. or the thermal resistant value of the air gap. Okay. Previously, we used to take a single figure and then multiply, and then that gives a lot of problem. And so I will give it to you again. This one here depend on whether it's a ventilated or non-ventilated airspace. Okay. So ventilated airspace with no reflective insulation, you can see the RSI value is only about 0.28. Whereas if you put in the reflectance, goes up to 1.9, nearly 3 times higher. Okay. Now naturally ventilated, it can go up to 1.3, almost again 3 times higher. So whether it's ventilated or non-ventilated will affect the how much heat transmit through your air gap. Now this is important because again, a lot of our clients, developers, they like to claim figures, very high figures, because they can use the air gap. Okay, so air is cheap, so they start using foil insulation, and they say, okay, my thermal resistant or U value of my lightweight roof already below 0.4. So that type of calculation is not acceptable anymore already. So this one is depending on the light category of roof. So I will go through a few typical of how these values are calculated. Okay. Now the first thing you need to do is you have to see the purlins. Okay. So if you, for example, if you have a metal deck at the top there, and then you have a airspace gap, and then reflective insulation, and then you have a rafter here. So those air gap values are derived from the RSI table. No more from thickness of air multiplied by density of air. No more already. So this is the value. So if you, for example, if you have a metal deck roof with a foil insulation, the foil itself is a very important value. The emissivity of the foil itself. There are a lot of different types of foil insulation. Foil insulation can be the high quality ones, which are used in, for example, the ones that they use insulating spacecraft. Those are the highest quality ones. Okay, emissivity value up to 0.1. Whereas if you use building paper and then you vacuum metallize a lot of aluminum on top of it, the emissivity can drop to 0.10. Okay, factor of 10. So that's why this is important. You can see based on the RSI table, you get a different value of calculation. So this one barely make it. Lightweight roof 0.4. Okay. Now this is based on the emissivity table, 5 degree. Then you can put in the two figure. You can see just now 0.7, 0.766, 1.34. Okay. This is where you derive the value from. Okay. Let's go to another one. If you put in the heavy, the thicker insulation, which is the mesh insulation, you can see straight away no issue of getting the U value for the roof. Okay. Now, I think also you have to remember, even within the the insulation, roof insulation industry itself, there are two groups on. One group is manufacturing all the, they call it the foil insulation, the bubble foil and all that. The other group is manufacturing the mesh insulation like rock wool and all that. And then each claiming different values. So sometimes they cannot agree. They start to contest each other's figures. This is where the RSI table came out from work between Green Building Index and the UKM. So we came out with those tables after discussion with the two industry. Then only the table was accepted. Okay, because there are a lot of other factors like how much dust is there on the foil. That affects the RSI value also. Okay, and how good is the emissivity of the value. So all those can be measured and to come out with the agreement. So this can see some of the values. So if this is the so if you're going for example, metal deck roof plus radiant barrier only, your U value is 0.47, cannot meet the requirement. Lightweight roof must be 0.4, so it's above already. Okay. Because of the IR of 0.109, this one here. Okay, attic airspace. If you ventilate it, then it's a different story. Let's give you another example. This one is radiant barrier only, and then you got roof pitch of 20 degrees. Foil insulation emissivity 0.03. Very high value, very good product. Enclosed airspace, okay? So what happens? You have the Berlin one, 0.75, 0.9. Okay? These are the figures that you derive from the RSI table. Okay? These tables are actually available at the Green Building Index website. Okay? Another example. Okay? Okay, this one just now I was talking about is the, okay, this is the tile roof, 0.52. You cannot, it doesn't meet the requirement, okay? 0.4 like tile roof is. Okay, next one is, for example, this one here, mesh insulation. The minute you introduce mesh insulation, your U value straight away go below 4 already. So you can actually go for this one. So if you are doing a housing project in Selangor or in Penang, this is now being strictly enforced already. A lot of developers trying to get the cheapest solution. You need to do your calculation properly. Okay? Tile roof plus foil insulation. So if you just purely on foil insulation, there's no way you can reach the value. You can see the U value is only 0.48. Very way over the value that you want. Okay. Now, okay, let's go back to this one, 0.40. If you have a ventilated roof, meaning there is either enough air to flow through the roof, calculation value can be done, the calculation value of the flow roof. Either that, or you have one of those extract fans on top of the roof. Okay, I think many of you have seen the roto fan. Whenever the wind blows, the air sucks out of it. This one is ventilated roof. You can see the attic space can get a value of 1.36. So you can barely make it, but of course you have one fall insulation, but it's a ventilated space. So you take the 1.36 ventilated roof. Okay, that's why you get the figure. You can barely make it. Of course, you have to buy the highest quality fall insulation, not the cheapest quality. Because it's already 0.4. If you take anything worse than emissivity, anything worse than 0.03, you will not meet the value. Okay. So assuming air resistant, what are the common areas? These are the areas that we find. A lot of consultants come to Malaysia from Singapore, submit things like this. Assuming the resistance is infinite, that means, like I said earlier on, the thicker the air, they say the higher the air gap, the bigger the what they call it, the air, the resistance of the air. Therefore, the U value can be met. No longer true already. If you come with this type of figure, calculate this way, you get thrown out straight away. Okay, not considering quality of the emissivity of the fall. So this is the other thing that is common mistake. Ventilated space in roof ceiling differ from non-ventilated spaces. That's why I show you the figure, isn't it? This one here. Ventilated and non-ventilated, your air resistant value is different. Okay. The other is not considering the roof angle. Finally, air gap above 125 drop in the resistance as the thermal resistance begins to drop, the thicker the airspace, because there is start to a lot of air flow inside the airspace itself. Okay, so this one is very important because in residential buildings, the roof U value is compulsory already now under bylaw 38A. So if your insulation or U value of your roof, you don't put in either mesh insulation or foil insulation, there's very little chance of you meeting the bylaw. Okay, you as architects, you got to know about that one because you simply sign the thing. Later on, the buyer might come after you. You know. Okay, a lot of developers, they always say they don't want to put insulation on the roof. Why? Because they say put there, the owner cannot see anything. You know. I better spend $2,000, put the aircon, you can see. You know, on already very short, cool. You know. But that's called false cool lah. Because short while only. Then you pay every aircon, you pay every month, you pay another $150 to $200 more in electricity bill. After 5 years, you could throw the aircon away, buy a new one again. Don't forget that. Whereas if you put in a proper insulation, the temperature, peak temperature will drop up to about 4 to 7 depending on the condition of the kick in through your roof. Okay. Just now, I think Mr. Lim showed you already. He said 10 degrees. We cannot get 10 degrees. Ours is between 4 to 7 like that at the most. A lot of the measurement done by UKM show that 4 to 7 degrees. So if your typical outside temperature during the night is 28, if you drop it by 4, you're around about 24, 20, 25, 26. You put on the fan, you will feel about 2 degrees cooler. No need to on aircon already. Okay, that's the big difference. Or you on the aircon less number of days. I wouldn't say you don't aircon at all. You can aircon, but those days where it's raining outside, you don't have to on the aircon already because the temperature inside the room is enough to have thermal comfort. Very important, thermal comfort and thermal in a healthy environment also. Because you put in the aircon all the time, the fresh air rate inside the room is very low. Unless you open the window and on the aircon at the same time, then a lot of headache also for you. Okay. Okay, thermal insulation for lightweight roof. How many mm can you go in until it reaches what they call the optimum value? This one, if you are doing a lightweight roof, up to 300 mm still got value. Heavyweight roof, not much value. Okay. Now, a lot of questions have been asked about MS1525 and MS2680. Okay, regarding the roof insulation itself. They say this one is for residential, the other is for non-residential. Well, under MS2680, they say the calculation method for OTTV and U value shall follow the method shown in MS1525. So actually they are merged together. It's the same standard, but one is purely on advisory factors for residential buildings, the other for non-residential buildings. Okay. Sorry, I rushed through too fast already. Actually, I want to slow down a bit so you can put out your hand and ask questions at any time during the sharing of the information. Okay. Finished. Thank you. I can back to you.
Can do the Q&A. Testing, 1, 2. Okay, thank you, Architect Chan. That was a very, very informative, very technical, heavy, very specification heavy presentation. I think we really appreciate the detail that you put in. So let's open it up to the audience. Who would like to get the ball rolling and ask the first question? I personally think it was so detailed that I really have no questions myself. So much of information in the past.
No, actually, I only scratched the surface. If you want to really do the work, you actually need to go into take one of the courses offered by Green Building Index. As a PAM member, you have, I think, a very good discount. They can give you a very good discount compared to, for example, outsider who come in.
Right. Okay, so he's basically advertising lah. Marketing and promotions are very cleverly slid into the presentation. But honestly, I mean, do you have any questions, especially regarding to GBI? I think that's obviously going to be more and more important over time. I mean, for instance, if you want someone some basic guidelines to familiarize themselves with the GBI or specific criteria that they need to look at before designing anything, then where can they get at least the basic guidelines to start off with? Is it downloadable from a website or something, or?
It's available at the Green Building Index website.
Okay.
And then also currently, I think maybe for architects, I think next year there might not be a lot of new work. So a lot of refurbishment work is going on. So when buildings refurbish, especially if they are done by corporate, big corporations and things like that, they have this new requirement under the Securities Commission, SC Commission. They want the building, they want their companies to be ESG, environmentally
sustainable and governance.
ESG, environmental sustainable governance, ESG, into their annual report. In order to reach that, I think about 30 to 40% of the points for that ESG come from the property they own. So if they refurbish their property, they have to get a green building certification. This is where you can see, if you can't even get your roof insulation value, your OTTV correctly, there's no chance you can get the green building certification. Whether it's a green mark or whether it's green building index or it is the the one that CIDB is doing, you cannot get it unless you can meet the basic requirement. That means you prevent the heat from going in, not more than 50 watts per meter squared for the envelope, not more than 25 watts per meter squared for the roof. Two things only you have to remember. You cannot get those figures out, there's no way you can get.
Okay, yeah. I think ESG is becoming more and more important.
Yeah.
Environmental, sustainable.
Unfortunately, you can see now only the accountants are doing it.
At the moment.
Yes, at the back, one question.
Oh yes, we've got a question at the back there. Please introduce yourself and where you're from.
Yeah, hello. I'm Mr. Lim. So regarding to the issues just now, like Sir said that if the architect did not apply a layer of insulation foil in accordance to the standard, then after the buyer, they found that one day if their house, the roof leak, then they found that there's no insulation there, they can sue the architect or the developer.
Obviously, they will sue the developer first because they have a contract with the developer. But then they also have the right to complain to the majlis that this one not put in the insulation.
Okay, this.
If that's the case, then what happened? The majlis will then direct that complaint to the board of architects, who will form up what they call it, inquiry panel, and then you get hauled up for that.
Even though maybe after 5 years, they found this thing, the owner found this thing happen, they still can sue it. Right?
Your as an architect, you know what your liability under the UBBL is unlimited and for life.
Okay.
Until they change the Limitation Act, the engineers have managed to bring it down to 15 years already. Unfortunately, I don't know whether the architects are in there.
Yeah, Limitation Act, I know that it's about 6 to 7 and they have certain period that after that you cannot sue them anymore.
Yes, that's for the one is Liability Act is under contract. But under the UBBL, there is no such limit on liability.
Okay, thank you.
I think the question was for Architect Chan, not for Mr. Lim, right? Yes. Okay, just wondering because I thought maybe we got the wrong guy. Okay, it's okay. Okay, yes, thank you. Yes, it's unlimited liability. So do make sure your roofs are all properly insulated. You know the developers, how they can be, contractors and developers. Next question, please. Do we have another question from the audience? I don't know, are there people who actually, can you hire people to come and check the building whether it's compliant with the GBI criteria, like consultants?
Yeah. Nowadays,
are
there are a lot of people called building inspectors. I don't know whether you have kena before building inspectors.
But specifically
you kena before, then you will know lah. They will come to the building. They will inspect everything and put sticker all over the place. No,
that one I agree, but specifically for GBI.
GBI, no, because if you claim your building is GBI rated, then they will inspect for GBI. If they include that into their scope, they will inspect for you.
Right.
And then typically, I notice, not in KL area, not in the Klang Valley area, but in the outskirts, outside the city center, a lot of time, architects make the mistake of not inspecting the thing before they install the ceiling. Okay? So the separation wall between units, they didn't plaster the brickwork. The other is they allow the timber or whatever lightweight trusses go right through from one unit. It's not allowed under the fire bylaw. No. You don't plaster the thing. So these so-called inspectors, they go there, they open the ceiling, they take picture, then they send it to the majlis. Majlis will then complain to the board. There, this guy never follow bylaw.
Ouch. Okay. Any more questions? Okay. It's all very scary actually. Okay, there's one question on the top there, the gentleman on the top.
Morning, I'm architect Chan. In view of this revised bylaw will be implemented, How would you foresee in future, how would this respective local council implement it? How would they implement it? How do they go about regulating it?
For example, in Penang, let's just show you a typical example.
Thank you.
When you submit your building plan, just like you submit your bomber plan to bomber, depending on which bomber officer you have to submit your building load calculation. No, for example, your escape capacity, your escape distances, your compartmentalization, all those need to be calculated, shown on a report, submitted to the bomber together with your plans. The same is in Singapore, in Penang, you have to submit your building plan together. When you submit, there's a checklist there, bottom there, U value calculation for roof. You got to submit it together with a section of your roof, detailed section.
Okay, thank you. Shall we take a few more questions? Oh, sorry, there's another one up there.
Has it been responded back properly? It's rather technical because this calculation. Bomba one, we are familiar as practicing architect, and we just say all things being equal, we don't take KLCC, that kind of super duper project that we normally in small practice don't get involved. Just say a complex 20 or 30 million worth of office building, so to speak. The bomba calculation, I won't say not that complicated, we can manage so far. Anyway, we need to get approval. But this energy thingy calculation appears to be complex to me as a practitioner. So how would they regulate? Because I would like to add that about 15 or 10 years ago, they started this, what they call it, what is it, the building efficiency calculation in terms of, what is it? I've forgotten the name.
Building energy index lah.
Not building energy index, it's in terms of industrialization, IBS system.
IBS,
basically, IBS system, I had a brief experience with certain council, and we submitted it in. So I don't know how, that as I equate the IBS system, very briefly, if there's no agreement, equally complex as your energy calculation. I struggle with it.
We are not calculating energy. We're just calculating the heat U value, which reflects the amount of heat going into your building. That means if you are doing residential building, only the roof U value you need to calculate. You don't have to calculate the OTTV. Okay? So roof insulation, you just draw a section of the roof, specify how thick your insulation is, how thick your wall is, your roof tile is, and then all that. Calculate all that, total it up, and then you give a figure of thermal resistance. Thermal resistance 1 over thermal resistance is the U value already. Okay, I think this one is, this is the duty of the architect lah. For example, you're talking about IBS. IBS is the structural system of the building. That one is done by the engineer, submitted by the CSS engineer, signed off by the CMS engineer. Very seldom got architect doing it now.
My understanding actually with IBS, there's different 3 categories. One is M&E has their calculation, structural have their structural system calculation. We architect has our IBS component calculation. So in the submission, architect as a sort of a secretary, we actually combine all and we submit.
Okay, agree. Okay, that one is the...
So in the nature of whether we calculate energy or whether we calculate the efficiency of industrial building system is immaterial. It is only a tool and a process that we go through. But to me, both are equally complex. Probably IBS is more complex. But when you apply a certain calculation to a product like building, which is actually quite complex, it can range from a simple, what they call a link house to, say, a factory office complex. So the calculation for a factory office complex can be actually quite complex. And I am a bit concerned that eventually they implement it. I don't understand because I've not submitted. I don't know how well the bylaw has been adopted by respective different local authorities. Thank you.
Like everything else, when they submit, for example, the structural calculation, together with the structural plan, do you think the local authority know how to evaluate or not? No way, ma. They just take it as a record only.
Yeah.
If something go wrong, then they will book out and see. The same thing with your calculation for your roof. Nobody complain you are safe and sound home already. But if one of the buyer employ a building inspector, bring out the thing, go there and shine torchlight, measure here and there, calculate back, and then you say this is not correct, you face the problem lah. That's all. So if you don't know, then I think unfortunately changing time, you got to change with the time lah. Just that this is part of life lah. You got to buildings are getting better, getting more expensive. The more expensive they are, the more fussy the buyer is. They will change everything they can find to make fault for you. So unfortunately, this is the way you practice lah. I hope they put the Limitation Act into the Architects Act very soon now, because this unlimited liability for unlimited time is not very good for us.
No, I can imagine it's not. No. I can imagine it's not.
Not good for us. Under the UBBL, we have unlimited liability. But under our contract with our owner or employer, whoever is the employer, like for example, if you're signing a contract with a developer using the PAM or LAM standard form of engagement, you can limit your liability very easily. I always put at the bottom there, the limit of my liability is how much you pay me. Yeah, you pay me 1 million and then you expect me to carry more than 1 million liability. I said, no way. I just put down there. A lot of them never see it. Sign only. Okay.
I hope you got that on video.
But unfortunately, the Uniform Building Bylaw is a separate part of the law. That is the liability you carry for life for the mistake you make if the building doesn't comply with the Uniform Building Bylaw. That one is unlimited because that is public liability. It's not, they're not under torts, they are not under contract. Okay? So you just remember those two. There are two different sets of laws.
Okay. The most important piece of advice today, yeah, that disclaimer. My fee is the limit of the liability. First thing Monday morning, I'm putting that in all the contracts also.
Yeah, the lower he pay you, the less he carry liability.
Yeah, no issue on my part, man. I agree 100%. Okay, we're almost at the end of the session. I think maybe just one last question. Just one last. Okay, the guy in front there, please. The one in the black shirt. Of course, I'm sure Architect Chan will be around. So if you want to ask him personally later, but I think by all means, it's not an issue.
Hi, Architect Chan. My question is there any separate calculation for green roof, landscape roof?
Green roof, like any other roof, it consists of components in it, different components in it. So your roof tile got a value for the thermal resistant value. Your earth has got a thermal resistant value. Your grass has got a thermal resistant value. It's matter for you to dig out the information only. So when you put, for example, if you put in, let's say, 300 mm worth of earth, then you put the thermal insulation value of the earth multiplied by the thickness. Then you total up all the thermal resistance. That is the total thermal resistance. Then you can actually how do you call it? Get your total thermal resistance. Now the green roof that Mr. Lim has been talking about, actually it's a very valuable asset to a building for the simple reason that you can actually put less insulation in. Insulation is not a cheap thing. You see just now Mr. Lim was talking to you about it. $300 per square meter, for the roof. Insulation plus the waterproofing membrane. I would say more than half the cost of that roof go into the insulation. So if you reduce the insulation, put in a proper how do you call it, membrane, and then you allow the roof to grow, like turfing and all that. You don't have to reuse so much insulation. A lot of developer in Malaysia, they kena psycho. They are thinking, hey, no, you put earth on top, start leaking everywhere, and this doesn't make sense at all. Because their experience is they go and buy the cheap insulation, cheap what do you call it, waterproofing membrane. put on top, and then they never put in any call it a root, root barrier, Then they plant small trees and bushes on top of it. The root just go right through their concrete, and then they start to leak. Of course, it will start to leak. So because of their non-consistency, they start to blame. They say, "Oh, you put a green roof, sure leak one." That's not the case, A lot of research done in NUS show that the green roof actually lasts longer than the normal roof. You know why? Because when you put in the, let's say, shrubs on top of it, then you put a layer of earth, then you water the thing. The water doesn't affect the so-called membrane or whatever waterproofing membrane, because the temperature at the rooftop now is very stabilized already now. Because at the peak last time, normally if you have bare concrete, peak temperature done by Dr. Wong, National University of Singapore, 58 degrees centigrade. Whereas he measured on a green roof with the planting and shrubs, 28 degrees centigrade below the shrubs. So imagine your waterproofing membrane, the peak temperature is very steady, not so high. You think it will last longer or not?
Yeah, protected.
It's protected.
Basically, for green roof, we give the warranty similar as a Reiner bond, and it's higher compared to mechanical fixing. The reason is the waterproofing is already protected from the weather elements such as UV, and yes, that's the main reason we give a longer warranty for the green roof. But the bad news is we don't have a chance to sell insulation already since
That's bad news for you, no?
You still need to put insulation.
I should earn waterproofing insulation one.
Okay, so
I think
the other thing you when you put a green roof into the building, what happens is you actually increase the area of the greenery. That improves your microclimate. For every I think 5% increase in your green area in your microclimate, you drop your temperature. So this is something which a lot of architects, if you are an architect, you got the opportunity to convince your client to do. Please put it in. It's a value both in terms of longevity of your waterproofing membrane, also improve your microclimate. There's no reason why you shouldn't do it.
Okay, I think, thank you so much, Architect Chan. I think that was the last question. I'm sure he'll be around, so I think if you want to ask him something after this, it's fine. So, ladies and gentlemen, we have come to the end of today's seminar. This remarks, of course, the end of the program, and of course, we want to thank all of you for being here today. Let's give both our speakers a round of applause. Of course, we all know Datum is just around the corner, so we hope to see you there as well. Until then, have a safe trip back home. Always remember the hashtag Kita Jaga Kita, and have a pleasant day ahead. Thank you so much, and see you soon.